from just above, surface area is going to be 4 times pi times r squared. Now, we know 4, because well, that's a number. We know pi, because that's in our calculators. And we're given the radius, which is, in this case, 1.5 inches. So this is my baseball. Remember, the radius is 1.5 inches. Now, that looks like a circle, but you can imagine it being three-dimensional. So this is pretty straightforward. We don't have anything sort of tricky. We can just plug everything right in there and we can get our answer. So 1.5 times 1.5 times pi times 4. Just plugging it into your calculator. You should end up with 28.274. Just continues on. It asks for the nearest square inch, so we're just going to leave it as 28 inches squared. So nothing too earth-shattering there. The next question asks us to find the surface area, or sorry, it doesn't ask us, it's telling us the surface area of a soccer ball is 250 square inches. What's the diameter of the soccer ball to the nearest tenth of an inch? So this is one of these sort of backwards questions where we're given the outside, the surface area of the ball, and we're asked to find the, in this case, the diameter. So from side to side through the center. Yeah, Abby, that last one is pretty straightforward. This one, in an attempt to make these questions a little trickier, they give us the surface area and asked us to find the diameter. Now, I'm going to write down our formula for surface area. Try to leave that up above there so you guys can see it for a second. Surface area is 4 pi r squared. Now, in the question we're talking about, we know this 250 is a surface area, and it's asking about a diameter. But I don't have a diameter in my formula. Hopefully you guys remember the relationship between a radius and a diameter. Maybe while I'm going through this, if somebody thinks they remember, they could throw it into chat there. And I can go back and look at that in a second. So I know the surface area is 250. I know 4, I know pi, and I know r squared. I don't know r squared, sorry, but I'm going to try to find it. So kind of the trick, radius is half of the diameter. Yeah, Devin, you're all over it. I'm going to write it like this. 2 times the radius is equal to the diameter. So what I'm going to do is I'm going to find the radius, and once I've found that, I can get the diameter from that. You guys are good. So I'm going to have to kind of work a little bit backwards, and this is where this algebra all kind of comes important. So I'm going to show a few steps here. Divide both sides by 4 pi. You could do 4 and pi separately, but I'm just going to do them as one step. So I'm going to end up with 250 over 4 pi is equal to r squared. And then in order to get r by itself, not times itself, I'm going to have to take the square root of both sides. So I'm going to end up with the square root of 250 over 4 pi. That square root all the way to the bottom, there we go, is equal to r. Now, I've written it all as like an exact value. I have the 250, I have the 4 and the pi, but at any point along the way you wanted to actually calculate what 250 divided by 4 pi was, then that's fine. I'm just going to do it in one step right now. So I'm going to, in my calculator, instead of going square root and then 250 divided by 4 pi, my calculator is going to get a bit confused on the order of operations. So what I'm going to do in my calculator is I'm going to figure out everything under the radical or the square root sign. So I'm going to go 250 divided by 4, and then I'm going to hit equals. And then I'm going to divide it by pi. And then I'm going to end up with this 19.89. Once I get there, I'm going to take the square root of that. And I'm going to end up with 4.4603 equal to my radius. Now that's, again, not what the question asked for. The question asked for the diameter of the soccer ball. So I know from what you guys had mentioned up above here that the radius is half the diameter, 2 times the radius is going to be the diameter. So what I'm going to do is I'm just going to plug this in here, and I'm going to end up with 2 times 4.4603 is equal to the diameter. So I get 8.92. And in this case, the nearest tenth of an inch. So I'm going to lose the 2, because that's my hundredths. Not squared, but just inches. 8.9 inches is the diameter. So you can see that these types of sphere questions tend to be a little bit more straightforward. There's no Pythagorean theorem. There's generally not a ton of steps kind of along the way. So the more difficult stuff is the stuff from the last section, and this stuff becomes a little bit more straightforward, which is kind of nice, because that last stuff does get hard. So the moon is an approximate sphere with a diameter of 2,160 miles. What is the approximate volume of the moon? All right. So we know the diameter of the moon, and we need to kind of think about what we're trying to find. So we're trying to find the volume of the moon. So maybe I'll start with the volume of a sphere formula. And 4/3 pi r cubed is the volume of a sphere, right off my formula sheet. Now, the only thing I don't know for my volume here is the radius. But the question tells me the diameter, and I know from up above, 2 times the radius equals the diameter. So the diameter is 2,160. I get 2 times radius equals that. Just gonna do a little bit of extra work here, just to remind us where this is coming from. You guys already knew it. The radius is just gonna be the diameter divided by 2. So 2,160 divided by 2, end up with 1,080. So 1,080 miles is going to be the radius. Now from that, I can just plug it into the volume formula. 4/3 pi 1,080 cubed. Now this may be where this section perhaps gets a bit tricky, is figuring out how to do this calculation in your calculator. So there's lots of different ways to do it. We know, of course, that we follow our BEDMAS rules always, but there's a 4/3 fraction at the beginning, so just kind of how you want to make that work for yourself. To me personally, I don't mind whatever way you do it. I just encourage you to be consistent with how you're going to do it. So I can explain how I do it. You can do it that way, or you can do it any other way. So some students will take the 4/3 and turn it into a decimal and then multiply that through. How I personally do it is I'd take that 1,080, I'd cube it first, then I'd multiply it by pi, then I'd multiply it by 4, just kind of working my way backwards, and then I'd hit equals, and then I'd divide that by 3 as my last step. So just kind of figure out how it works in your own brain and just be consistent with how you're using these formulas, especially the volume one, because you're always going to end up with that 4/3. So this is literally how I'm putting it in. I'm going to take the 10,080, I'm going to cube it. Some of you may not have a cubed button on your calculator. If you don't, that's fine. Just multiply it by 10,080 and then times 10,080. So you're just multiplying it by itself 3 times. It's going to end up with the same thing. If you can find a cubed button, perfect. Some of you will have a y to the x button, which will work. It just depends on your calculator. But for now, if you just want to write 10,080 times 10,080 times 10,080, that should work. And then I'm going to multiply it by pi. And then I'm going to multiply that by 4. Then I'm going to hit equals. Oh, I keep saying 10,080. Sorry, Alex, thanks you for correcting me. 1,080. I'm seeing zeros that aren't there apparently. So 1,080 times 1,080 times 1,080 times pi times 4. So I'm kind of working my way backwards across the equation. And then once I get that, it's going to be a really big number because that 1,080 is a very large number when it's multiplied by itself 3 times. And then I'm going to divide that whole thing by 3. Your calculator is going to give you a very, very, very large number. And if you think about what we're dealing with here, we're dealing with the moon. So it rightly should be a very large number. What I end up with on my calculator is a whole bunch of digits that looks like 5. I'm just going to write it right in scientific notation. Have you guys, do you remember scientific notation? Have you seen scientific notation before? Anybody seen something like that before? Your calculator may throw it in as with a little E here at the end. Sometimes it throws it in with an E. Give me like a, yeah, I've seen scientific notation before, or no, I haven't, Mr. Borden. I'm very confused. Taylor, I've done it. Well, can we go over how to do it? Excellent. Yes, we can. Let's see if I can get that answer back up. So this is what I had in my the window of my calculator. 276669286. A long time. All right. So this is what my window said in my calculator. It has all of these digits, and I need to figure out exactly what I'm doing here. So anytime we put a number into scientific notation, it's going to be between 1 and 10. So in this case, I'm going to move my decimal from the very back. I'm going to move it over step by step. And don't think because this one question has this scientific notation stuff in it that's going to be something that comes up a lot. It just kind of worked out that way for this question. So how many times did I move my decimal over? There was 1, there's 2, 3, 4, 5, 6, 7, 8, and 9. So I moved it over 9 times. So that's what my exponent's going to be. So that's where I'm just going to round the 27 to 3, 5.3 times 10. The 9 was how many times I moved my decimal across. And then I remember this is miles and then cubed. So hopefully that's a bit of a refresher on that. And again, it's not going to come up a lot this part of the course, but that's just how I did it. So there you go. The next question, I wish this had dropped down to the next page, but it didn't. So I'm just going to see if I can get between the pages. Hemisphere has a radius of 5 centimeters. First of all, do we remember what a hemisphere is? Do we recall what a hemisphere is? And I will mention that your formula sheet doesn't have any mention of hemispheres, but sphere, hemisphere. When we're talking about a hemisphere, we're talking about half a sphere. Perfect. And in this case, the radius is 5 centimeters. Good. So hemisphere, half a sphere. This one asks for the surface area of the hemisphere to the near 10th of a square meter. This is kind of like we have a nice little picture drawn here. The questions that we were doing in lesson 4's practice. What is a hemisphere? What makes up my hemisphere? If I'm thinking of taking a paintbrush and covering the outside, figure out exactly how much paint takes up the outside and that bottom, what shapes am I dealing with? And what do I know in terms of my formulas? And what can I use and kind of what can't I use? So anybody think about this hemisphere? The picture here, we have a couple of shapes that we're dealing with. So what shapes are we dealing with? What is the base of my hemisphere? What's the bottom? Just draw it in red here. What shape is that? It's a circle. Abby was on it. So I have this red circle. So I have circle. And then if I don't know how I can shade it, but I have this half a sphere. So I don't know, I could write it as 1/2 a sphere. So that's going to be my surface area. Hopefully that makes sense. I have that blue half a sphere, and then I had that red circle on the bottom. So if I can find the circle and the half a sphere together, I could probably just add them together and figure out what the surface area is going to be. So this is where this section gets kind of a bit trickier. The circle, we know the area of a circle. Even if you don't, it's pi r squared. And then I'm going to add to that half a sphere. So I'm going to take 1/2. The surface area of a sphere formula, you maybe recall, is 2 pi r squared. And that again is just right off the formula sheet. We don't have to memorize these things. So I know that this particular one has a radius of 5. So I can just plug that in. So I have my pi times 5 squared. I'm going to add to it. What happens to my a half times 2 here? It just kind of goes away. It turns into 1. So a half times 2 is just 1. You can leave it if you want. Maybe I will. Half of 2 pi, and in this case I have 5 squared. All right. I think I've made a mistake on I sensed something was wrong. My spidey senses were tingling. The surface area of a sphere is 4 pi r squared. Abby, you caught me on that one. That makes more sense. I'm happier with that. All right, now step by step going through this, I'm going to have this pi times 5 times 5, or pi times 25. So what's that look like? 78.54. I was a step ahead of myself. I'd already multiplied the 1/2 times 4. So this 1/2 times 4 is just going to be 2. Or you can go 4 times pi times 25 and then divide it by 2 if you want. You'll end up in the same place. 2 times pi times 25. It's 157.08. So I get 235.6. So that's going to give me my surface area of a hemisphere. And then the last part of this section, got a couple minutes left, is the volume of the sphere. So volume of my sphere is 4/3 pi r cubed. But I don't want the full sphere, I want yes, Abby asking a really good question about would we estimate those two and then add them because it would be difficult to plug them both into calculator and add them. Yeah, we can, I would just maybe carry 2 or 3 decimal places on my screen. Or you notice that when I actually did the question, it asked for the nearest tenth, but when I was doing the question, I kept to the hundredths column, and that way, that's strange. That way, when I rounded, I knew I was going to round to the tenths column. So just kind of a way to make things a little bit easier. I'm just going to finish this off in the next 5 minutes here. What's the volume of the hemisphere to the nearest tenth of a cubic meter? So I'm not talking about a full sphere. I'm talking about half of it. So I'm just going to divide it all by 2 at the very end. It looks kind of funny when I write it like this because I have a fraction on top of a fraction. But, I mean, it's nothing that, you know, as long as you kind of can wrap your brain around what it's going to look like, you should be fine. So I have 4/3 times pi. In this case, my radius is 5. And then once I've figured out all of that, I'm just going to divide it all by 2. So, again, you might not have a cube button in your calculator, so you're going to go 5 times 5 times 5, which is 125. Order of operations says we should do our exponents first, and then I'm going to multiply that by pi, and then I'm going to multiply it by 4, and then I'm going to divide by 3 at the end, which ends up looking like 523.599 over 2. So all I've done is just calculated the top. Once that's done, I'm going to divide it by 2. And I'm going to end up with 261 point, in this case, 799. Or 261.8. So that's it for this stuff. And hopefully, get out of the way here so you can have a look at that if you're still copying down. Hopefully you found this stuff a little bit more straightforward than the previous stuff. And I know that the surface area of the cones and pyramid stuff is a lot harder than this sphere stuff. So if you got really hung up on the last section, section 4, then hopefully today's lesson will be a bit of a break. So if you're having any issues, I know I promised Ava and now Abby has a few additional questions that I would go through. Maybe I'll tell you what, we'll maybe slow this section or unit down because the next unit we do is pretty quick one, unit 1. So what I'll do is we have class on tomorrow, which is Wednesday, and class again on Thursday. What we'll do is we only have one section left, which is unit lesson 6. So I tell you, I will go through more questions on lesson 4 next day at the beginning of class, and then I'll go through lesson 6 real quick like I kind of did today. I have a feeling that most of the sphere stuff is going to be pretty straightforward for you guys, so I don't think there'll be a ton of questions on it, but if there are, that's fine. So I promise I'll spend some more time next class going through the lesson 4 stuff. So you really, really do need to attempt that quiz for the lesson 4. And yeah, you should definitely do the unit 5 or lesson 5 practice. You should be maybe starting your learning guide in preparation for the end of the week. So hopefully you can get that test written by Tuesday or so. Maybe at the earliest, maybe Wednesday next week. because we are going to continue on with new lessons. So there you go. I have to run to my next class. Thanks very much for signing in today. Mrs. Wood is doing some ADC planning stuff right now. So if you guys could go ahead and sign back into her chat. Do we do the lesson 5 quiz? If you're comfortable with it, yes, do the unit 5 quiz. But if you are uncomfortable, you want me to go through a few questions next day, that's fine. So back into ADC planning with Mrs. Wood. Taylor, I'll talk about that at the end of the week, the learning guide, submitting it. And yeah, hopefully I can have a chance to go through that one question I made a mistake on, and I'll figure out where exactly I went wrong. So we'll see you guys tomorrow morning. Thanks.